So we can easily compute the probability that x is in some set and y is in some other set, or possibly the same set. It doesn't really matter. This is equal to the probability that x is in A and y is in B. Oops. Probability that x is in A times the probability that x is in B. But because the question is asking about the probability that at least one of the variables is greater than 3, we're going to translate this into the problem of both variables being less than or equal to 3. So we want the probability that x is less than or equal to 3 and y is less than or equal to 3. And that's the probability that x is less than or equal to 3 times the probability that y is less than or equal to 3. And that's equal to the probability that x is less than or equal to 3 squared, because both variables have the same distribution. So these are the same. These two numbers they happen to be the same number. So I'll just write it like that. Okay, so what's the probability that x is less than or equal to 3? Well, it's a half plus a quarter plus an eighth, 4 over 8 plus 2 over 8 plus 1 over 8. So that's 7 over 8. So the probability that x is less than or equal to 3 is going to be 49 over 64. Sorry, this squared, 49 over 64. But that's the probability that both of them are less than or equal to 3. We want 1 minus that. (49 over 64), that's equal to 64 minus 49, 15. Because if it's not true that both are less than or equal to 3, then at least one of them must be greater than 3. And this is option B. 15 over 64. Yeah, I think I did this correctly. The fact that all of my arithmetic ends up with one of the answers that's given means I don't think I have an arithmetic mistake. Yeah, I can't see where I might have gone wrong with this. The way you make this easy is simply by inverting the question to something that's a lot easier to answer. But remember to subtract that number off from 1 at the end. And I guess also keeping in mind x and y have the same distribution, but they're independent, so they're clearly not the same variable. Yeah, I'll let you know if there's a mistake in this one somewhere though. Thanks for watching.